Now we try to solve one numerical example based on a Gauss elimination method, how we find the inverse with the help of a Gauss elimination method. So here already we write a matrix A. So what is the matrix A? A is a 3 minus 1 1 minus 15 6 minus 5 5 minus 2 2. Now we try to find out the inverse of this matrix using the Gauss elimination method. So what is the first step? First step is to find out the solution. Let A inverse equal x11 x12 x13 x21 x22 x23 x31 x32 x33 with the inverse of matrix A, with the inverse of a matrix A. Then we know that A into A inverse equal what? A into A inverse equal identity matrix. Now since A into A inverse equal identity matrix, so here we write A. Now putting the values of A and A inverse, A is a what? Here A is a 3 minus 1 1, and this one is a minus 15 minus 15 6 minus 5 5 minus 2 and 2. Here we write the A inverse. Here we assume that A inverse is a what? x11 x12 x13 x21 x22 x23 x31 x32 x33. This one equal identity matrix, means a 1 0 0 0 1 0 0 0 1. Now we convert this equation into a 3 set of a system of a linear equation. We convert this equation into a 3 set of a system of a linear equation. So what is the first set of a system of a linear equation? Here we write a first set of a system of a linear equation, 3 minus 1 1, 3 minus 1 1, and second one is a minus 15 6 minus 5 minus 15 6 minus 5, and third row is a 5 minus 2 2, 5 minus 2 2, 5 minus 2 2. First set of a system of a linear equation is a x11 x21 x31. This one equal 1 0 0. Second system of a linear equation is a 3 minus 1 1 minus 15 6 minus 5 5 minus 2 2. Here we write a second row of A inverse, second column of A inverse. This one is a x12 x22 and x32. This one equal 0 1 0. So suppose this one is equation number 2, this one is equation number 3, and here we write a equation number 4. 3 minus 1 1 minus 15 6 minus 5 5 minus 2 2, and here we write a what? x13 x23 and x33. This one is this one equal to the third column of a unit matrix, and this one equal 4, equation number 4. Now we solve this system of a linear equation, second, third and fourth. We may solve these system of a linear equations separately, but this will consume more time. So in order to save the time, here we solve all the system of a linear equation simultaneously. Why? Because the coefficient matrix A is the same in all system of a linear equation. In a second system of a linear equation, A is the same. A is the same in a third one also, A is the same in a fourth one also. So here rather than to solve separately, here we try to solve simultaneously by writing the augmented system rather than writing augmented matrix. So what is the augmented system? So in the next page we write augmented system. So augmented system is a what? Augmented system is a, here we write a partition I, this one is augmented system. So now this one equal, here we write a matrix A. Matrix A is a what? Matrix A is a 3 minus 1 1, 3 minus 1 1, 3 minus 1 1, and second row is a minus 15 6 minus 5, minus 15 6 minus 5 minus 5, and third row is a 5 minus 2 2, 5 minus 2 and 2, 5 minus 2 and 2. So this one partition, here we write a unit matrix 1 0 0 0 1 0 0 0 1. So this one is a what? This one is a augmented system. Once we check the values of A, 3 minus 15 5, 3 minus 15 5, then 1 6 minus 2, 1 6 minus 2. So here we write a minus 1 6 minus 2, 1 minus 5 2, 1 minus 5 2. Okay. So now we try to convert, because here we try to solve the we try to find out the inverse of A with the help of a Gauss elimination method. So we try to convert this one into a upper triangular matrix. We try to convert the matrix A into a upper triangular matrix. For this one, first we choose the pivot element. Pivot element equal what? The common element of a first row and first column. So this one equal what? This one equal 3, and this one does not equal to 0. Why here I am writing this one does not equal to 0? Because only we able to apply the Gauss elimination method if pivot element does not equal to 0. If this one equal to 0, then we perform the partial or complete pivoting. So pivot element equal 3, then we perform the elimination of a first variable from the second and third equation. For this one, what is the pivot row? Pivot element is a 3, then pivot row is a pivot row equal R1. Pivot row is a R1. Now we perform the elimination in a second row, then we perform the row transformation R2 minus coefficient of this one means minus 15 divided by pivot element is a 3, then pivot row. You may also say this one is equivalent to what? This one is equivalent to R2 plus 5R1. R2 plus 5R1. Similarly, to eliminate the first variable from the third equation, we use the R3 tends to R3 minus coefficient of a first variable in a third equation, this one is a 5, divided by pivot element is a 3, pivot row. This one is a pivot row. So here we write a pivot row R1. So only we perform these transformation. Non-pivot row minus coefficient of a non-pivot row, first coefficient of a non-pivot row divided by the pivot element into pivot row. So this one is a way how we eliminate the first variable from the second and third equation. Now what is the equivalent system, augmented system? There is a no change in a first equation. So 3, there is a no change in a first row, 1, partition 1 0 0. Now if we perform the R2 plus 5R1, then this become R2 means this one minus 15 plus 15, this become 0, 6 minus 5, this become 1, 6 minus 5, this become 1, and minus 5 plus 5, this becomes 0, and this become 5r1, then this become 5, and there is a no change in these values. And similarly, r3 minus 5 by 3. So this becomes 0. So minus 2 plus 5 by 3, this become minus 5 by 3, be multiplied, this become 5 by 3, minus 2 plus 5 by 3, this become minus 1 by 3, minus 1 by 3. And here 5 by 3 means 2 minus 5 by 3, this become 1 by 3, 1 by 3, and this become 0, and this one is not a 0. So here be multiplied by the 5 by 3 here, minus 5 by 3, so this become minus 5 by 3, minus 5 by 3, 0, and this one is also a 1. So if we closely observe, when we eliminate the first variable, there is a no change in a identity matrix of a second column and third column of a identity matrix, only change in a first column of a identity matrix. So when we solve, there is a need to observe this property also, means there is a change in a first column, not in a second and third column, in order to avoid the error. So now this one is a minus 5 r3 minus 5 by 3 r1. So obviously this one is a this one. Now here in a reduced augmented system, what is the pivot elements? Now here the pivot element second row, second column, common element of a second row and second column. This one is a what? 1, and this one also does not equal to 0. This one also does not equal to 0. So there is a no need of a partial pivoting or complete pivoting. So here we try to eliminate the second variable from the third equation. So for this one, we perform the transformation on R3. R3 tends to R3 minus what? Minus 1 by 3 coefficient of this variable, minus 1 by 3 divided by the pivot element. Pivot element is a 1, then pivot row, non-pivot row minus pivot row, and here we multiplied by the coefficient of a non-pivot row divided by the pivot elements. So you may also write this one equivalent to the R3 plus 1 by 3 R2, R3 plus 1 by 3 R2. So here what is the reduced form? This one is a 3 minus 1, 1, there is a no change in the first row, 1, 0, 0, and this one become what? 0, 1, 0, 5, 1, 0. There is a no change in the first and second row. In the third row, we multiplied by the R2 by the 1 by 3. So this one is a 0, this one is a 0. Here we multiplied by the 1 by 3. So there is a no any change here. This become 1 by 3, and here this become 5 by 3, and so this becomes 0, and here this become 1 by 3, 1 by 3, and this become 1. Now if we closely observe, now this one converted into a upper triangular matrix, upper triangular matrix, upper triangular matrix, upper triangular matrix, triangular matrix. So in a Gauss elimination method, once we converted the matrix A into upper triangular matrix, then we write a reduced form of a system of a linear equation. So here, rather than to say reduced form of a system of a linear equation, here we write a reduced form of a set of a system of a linear equation, because what is the unknown corresponding to the first column of a partition matrix of a right hand side? x11, x21, and x31. So now we write a reduced form of a system of a linear equation. Reduced form of set of a system of linear equation. Set of a system of linear equation. System of linear equation. Linear equation. So what is the reduced form? Here we write a first system of a linear equation, this matrix A, 3 minus 1, 1. So this one is the first equation become 3 minus 1, 1, and 0, 1, 0, 0, 1, 0, 0, 1, 0, and third one is a 0, 0, 1 by 3. 0, 0, 1 by 3. Now, unknown of a first column with the x1, 1, x2, 1, and x3, 1. This one equal first column of a partition matrix. What is a 1, 5, 0? 1, 5, 0. Here we write a 1, 5, 0. This one is a reduced form of a first set of a system of linear equation. Now second matrix A remains unchanged, 3 minus 1, 1, 0, 1, 0, 0, 0, 1 by 3. And what is the unknown? Unknown be the x1, 2, x2, 2, x3, 2. This one equal second column of a right hand side. Second column of a second matrix of the augmented partition matrix. So 0, 1, 1 by 3. 0, 1, 1 by 3. 0, 1, 1 by 3. Third one is a again, here we write a third one, 3 minus 1, 1, okay, 0, 1, 0, 0, 0, 1 by 3. And what is the third unknown? Means a third column of a A inverse. Third column of A inverse is a x1, 3, x2, 3, and x3, 3. This one equal what? This one equals 0, 0, 1. There is a no change in a third column, 0, 0, 1. 0, 0, 1. Now, as we know that in a Gauss elimination method, after reducing the augmented system or augmented matrix into a reduced form of augmented system, then we perform the back substitution. So now by back substitution we try to find out the values of these unknown, means values of a first column, values of a second column, and values of a third column. So here we perform the back substitution. Back substitution. Back substitution. Back substitution. Okay. So in a back substitution we try to find out the values of a x31. So the value of a x31 equal what? The value of a x31 equal 0. The value of a x31 means a 1 by 3 x31 equal to 0, then x31 equal what? x31 equal to 0. So once we verify this one, x31 equal to 0. Now we multiply this row, second row, by this column, then what is the value? So here, rather than to write x31 here we write a x31 equal to 0, because 1 by 3 is third row and this column vector, then 0 into x11, 0 into x21, 1 by 3 into x31, then this become x31 equal to 0. Second row by this column, then the value of a x21 equal what? x21 equal 5. Because here we multiply 0 into x11, 1 into x21, 0 into x31, then we find the value of a x21. Now here if we multiply this one, then this one is a 3x11 minus x21 plus x31 equal to 1. If we simplify this one, then what is the value? The result become what? The result become, here we put the value of a 3x11. x11 minus 5 minus 5 plus 0 equal 1. So what is the value of x11? The value of x11 become 6 by 3 and this one equal 2. So here we write a value of x11 equal what? X11 is a 2. X11 is a 2. In a similar manner here we try to find out the value of x32. Here the value of x32 is 1 by 3, x32 1 by 3, this one is a 1. Now value of x22 is 1 and values of x12, this one equal what? This one equal minus time of minus of this one, so this one become, so here 3, once we write this equation multiplied by this one, so 3 x12 minus x22 plus x32, this one equals 0. So 3 x12 minus this become 1 plus 1, so this becomes 0. So x12 becomes 0. This implies that x12 becomes 0. So here x12 equal 0. So this one is a value of what? 0, x12 second column. Now here if we perform the back substitution in a third system of a linear equation, then x33 is a what? x33 1 by 3, x33 is a 1 by 3. Now what is the value of x23? x23 equal 0, and if we perform here 3x1 and here 3x13 minus x23 plus x33, this one equal to 0. So 3x13 minus x23 be the what? x23 be the 0 plus 1 by 3. So x13 is a what? Minus 1 by 3. This one is a minus 1 by 3 into 3. So x13 is a minus 1. So x13 is a what? x13 is a minus 1. x13 is a minus 1. So this one is a value. Now what is the A inverse? A inverse is a what? A inverse is a, if we started from here, this one is a inverse. x11, x21, x31 means the first column, second column, third column. Now we write the values of x11, x12 and x13 here. Now if we write here, now A inverse equal what? A inverse equal this one, x11, x12, x13, x21, x22, x23, x31, x32, x33. Now if we put the values of this one, values of this one, x11, what is this one? x11, this one give the first column 2, 5, 0, and second column be the 0, 1, 1, 0, 1, 1. Third column be the minus 1, 0 and 1 by 3, minus 1, 0 and 1 by 3. So this one is a what? This one is a inverse. This one is a inverse. Once we verify the result, either this one is a correct one or not. So A inverse is a 2, 5, where is a 1 by 3, x33 is a 1 by 3. So this one is a x33 is a 1 by 3 or not. Here x33 is a 3. So how we say that? Sorry, this one is a x33 is a 3. So there is a something wrong. 1 by 3, x33. So x33 is a not a 1 by 3. So this one is a what? This one is a, sorry, this one is a 3. So this one is a what? This one is a 3. This one is a 3. So this one is a 3. So 3x1 by 3. So this one is a what? This one is also a 3. This one is a 3 by 3. So this one is a 3xy3. So minus 3. So this one is a minus 1. So this one is a value. Okay. So if we write correctly here, so correctly here, this one is a minus. So here we write a minus 3 by 3. This one is a minus 1. So rather than here we write a what? Here we write a this one. So this one is a minus 1, 0, and here we write a what? Here we write a 3. So this one is a value. So this one is a what? This one is a how we find the A inverse with the help of a Gauss elimination method.